the temperature will be half a degree warmer by 2100 at the current rate of rise. This indicates the atmosphere is not very sensitive to increased carbon dioxide. Now, this is the Vostok Antarctic ice core data. The green is carbon dioxide levels going back 400,000 years, and the blue is temperature. What we found was that the temperature rises first, and then the carbon dioxide rises in the air, and the lag is 800 years. So increasing levels of carbon dioxide are not the result of warmer temperature. Let's see, did I read that right? Increasing levels of carbon dioxide are the result of warmer temperature, not the cause of it, at least in the past. Now, the ice cores say that carbon dioxide levels were around 270 parts per million during most of the last 10,000 years. This is the level of carbon dioxide in the air in parts per million as measured by ice cores until recently. But look at the temperature. It was going all over the place. So obviously this was not changing this. Something else was. The evidence proves that carbon dioxide has not been controlling temperature during the interglacial period. Does the way we measure temperature make a difference? In the country, you have cooler nights because there's less buildings and pavement and things. In the cities, they're warmer because of all that asphalt that gets heated up by the sun during the day, and just like the hot rocks around a campfire, that heat radiates to space. It keeps you warmer at night. It's known as the urban heat island effect. During the day, it's going to be warmer in the cities because of the buildings. It's going to be cooler in the country because of the gardens and the trees and the farms and all that. At night, it's going to be much warmer in the city than in the countryside because the grass and trees radiate heat to space, whereas the buildings have accumulated heat from the day, and that keeps it warmer. Here's Chicago in 1850. That's the whole city. Here is 1900. Here is 1950. And here is today, and the Cubs still haven't won. Your weather station that was on a farm in 1900 is now surrounded by urban sprawl. That changes the temperature, but not because the whole climate necessarily changed, because the microclimate around the station did. So it corrupts the data. Now this is a very revealing graph. You know, you probably noticed we love graphs. This is the near city urban raw data from 1900 about to the current. This is the trend of temperature near city urban. This is the country. This is the city temperatures. This is the country. You can see there is a significant difference between what's happening near the cities and in the country. So the growth of cities around thermometers has caused an artificially warmer temperature. Now, there's also the sighting issue, where you put the thermometer. Now, this is Tucson, Arizona. It's supposed to be over a grassy plot at least 100 feet from any influences. It's over pavement with cars and buildings. Terrible. This one is near an air conditioning vent. This one is downwind of where jet planes take off. Sloppy. Very sloppy. So bad placement of thermometers has also caused an artificially warmer temperature. And that's part of this. How much is debatable, but it's part of it. Part of the rise. Due to global warming, hurricanes are bigger and more frequent. There has been a tremendous amount of destruction from hurricanes in the last 20 years. There's no doubt about that. We've seen it over and over and over again. The North Atlantic Ocean warms up and cools off in a cycle lasting 60 years. It's called the Atlantic Multidecadal Oscillation. We also like big fancy terms like that. It just warms up for 25 to 30 years, and then it cools off for 25 to 30 years, probably driven by salinity differences. So here it is, warmer for 25 to 30, cooler 20 to 25, warmer for 25 to 30, and so on. When the ocean is cooler, like it was in the 1960s, 70s, and 80s, fewer hurricanes and fewer big ones. A hurricane needs fuel, just like a car does. And the fuel is hot, humid air that you find in the tropics. So when the ocean is cooler, there isn't quite as much high-octane fuel available to run the hurricane's engine. So you get fewer of them and fewer big ones. When the water's warmer, like it was in the 30s, 40s, and 50s, and since the mid-90s, many more hurricanes and many more big ones. Now, the Atlantic has been warmer since the mid-90s. And as you can see, from 1970 on to this period, these are the tropical storm numbers and these are the hurricanes. There has been no increase in both the number of tropical storms and hurricanes. In fact, when you develop an index called the Accumulated Cyclone Energy Index, where you take the energy of all the storms around the world and combine them, you find that that number has been decreasing since the mid-90s. So they're not getting stronger. Apparently around the world they're getting weaker. Now, are we making hurricanes worse? Said Time magazine in 2005. In 2005, we had 28 named tropical storms, that is a wind with 39 miles an hour, 15 hurricanes, a tropical storm with winds of at least 74 miles an hour. All-time record. See, today we have eyes in space that can see all the storms no matter where they are. They can't hide. That wasn't the case in the past. See, in 2005, actually, technically, there were 27 named storms and 15 hurricanes. Looks like an Italian dinner. You know, just spaghetti everywhere. These are the tracks of the storm. In 1995, 19 named storms and 10 hurricanes. This is 1887. 19 storms that would have been named had we named them then, and 11 hurricanes. But without satellites, we couldn't see the ones in the eastern Atlantic. 1916, 15 named storms and 10 hurricanes, but no satellites. 1933, 21 named storms and 10 hurricanes. If you had had 4 or 5 more out here, that becomes 25 or 6. That could become 12, 13, 14. The numbers start to look more like 2005. And there has been no Category 3 hurricane that has hit the United States since 2006. So we've actually been kind of in a quiet period. So the answer, are we making hurricanes worse? No. The natural cycles change the numbers and strength. And unlike the past, satellites see all of the storms today. We missed a lot of them in the past. Sea level will rise and flood coastal cities. This is the biggest threat from global warming. As the glacier melted, sea level went up 400 feet from 20,000 to 7,000 years ago. That's a lot. Since then, the rate of sea level rise has been much less. Tidal gauges around the world indicate about 8 inches in the last 100 years. The National Oceanic and Atmospheric Administration says it's only about 4.5 inches per century. Here's Boston, Massachusetts. The level since 1920 has gone up at a rate of 10.3 inches per century. Key West, about 8.8 inches per century. Sydney, Australia, rising at 2.3 inches per century. And Mumbai, Bombay, India, about 3 inches per century. And this is Honolulu, about 6 inches per century rise. What's this? Helsinki, Finland's falling at 9.5 inches per century. Oslo's falling at almost 18 inches per century, and Juneau, Alaska's falling at 51 inches per century. Why? Well, that's because the land is not sitting around. The land is moving up and down too. So where the land is rising, sea level falls, and where the land is sinking, sea level rises. So you can't just look at these things and make determinations about what sea level is doing. But recently we got good data back from the Gravity Recovery and Climate Experiment satellite called GRACE, a tandem series of satellites that accurately measure sea level. And GRACE says the world average sea level rise is about 4 inches per century. So real-world measurements, again, do not show dramatic sea level rises occurring. Now, some predict an ice-free end-of-summer Arctic soon. See, in the Arctic, in the winter, it all freezes over. Then in the summer, when the sun is out, it melts, but not all of it. The melting ends about the end of the first week of September. Now, there are 19 different polar bear populations around the world. They live in Russia, Alaska, Canada, and Greenland. In the 1960s, there were an estimated 5,000 polar bears on Earth. Today, the estimate is 25,000. In fact, polar bears are at an all-time high of abundance level. The only reason the service, the U.S. Fish and Wildlife, listed them as threatened was based on speculation from fairly untested models based on what the fate of polar bears may be in the future. That was Doug Vincent Lang, Alaska's coordinator for endangered species. There's more of them than ever. But if you read the Time magazine Vanishing Act in the April 2009 Extinction Edition, Time said there were only 25,000 left. In reality, that represented a huge increase in the population. but the story had major input from environmental